Good evening, sir.
Right. Good evening, all. I think today we have to start our new chapter, which is program development, right? So I think we have discussed about the Sinhala keyboard last day and installing about the Sinhala keyboard and the workbook part, right? So let's move with the new chapter, program development. Actually, part of this lesson you have already learned in grade 6. How many of you have learned that in grade 6? Program development, the flowchart part? Can you remember that? Yes, Ali, can you remember that?
Sir, I haven't done it in grade 6.
Grade 6. You are not coming to grade 6 classes, Ali, right? So I think you better come to, so we have just finished.
Yes.
Right, we have just finished it in grade 6 class. You could have come and learn that because that is free. And anyway, we have finished grade 6 lessons now, but if you have not done, you could have come and learn. Grade 6 free. Okay, how many of you can remember the lesson so which you have learned in grade 6?
I can, sir.
Okay. Sandaru, Tania, can you? No response. So you have to put a when you turn on the mic, ekapara off karanne epa on karala. Etakota apita මේ කියන්නේ ඇහෙන්න කලින් off වෙනවා. But you will feel that you have turned on and talk, but before we hear, it will be like muted. Okay, so anyway, so if you have not learned in grade 6, don't worry, but the thing is that, okay, so those, if you have not learned that, so my recommendation is please come to grade 6 class also, because it is just before this. We conduct grade 6 class from 6:20 to 7:20. You could have come there. At least come. So next week we will be starting our new chapter, internet email, in grade 6. I invite you to join with grade 6 also. So you can come to the both classes, right? Grade 6 and 7. Then you can learn it. Okay. Right. Okay, let's go and learn about the program development quickly. And before we begin, I just want to introduce what is a program, what is a software. So software or program, right? Software or program. So you can tell that that is a way of instructing the computer to do something. When you want to instruct the computer to do something, you use program or software. It is actually a set of instructions. Right? Okay, so first of all, shall we write this note? I'll explain one by one. First of all, shall we write this note under the new chapter, program development, small note? Please write that. I'll explain one by one after you write this, right? Right. In this chapter, what we are going to learn is about how to develop or how to write a code, right? A coding or program is a way to explain something to the computer. How we explain things to the computer is by using a program. Okay, when we get things done using a computer, we have to write programs to explain that the actual program is a set of instructions. It is step-by-step instructions or way of instructing a computer to do something, right? So basically, when you have a complex problem, difficult task, we divide into manageable, understandable, small pieces. So we call that is decomposing, right? So that is there in your book, right? Let's go and see what's there in your book first under this chapter. So let's go to the book, and this is grade 7 English medium reading book. Right. Oh, not this. Okay, here it is, and you can see under this chapter, the first thing that they have mentioned is about the decomposing of problems. decomposing. That means when you have a complex task, a complex shape like this, you can see, so this can be explained by using more simple shapes like circle, and so this is like a cross, diamond. So this is called decomposition. When you decompose a problem, it's basically easy to solve, easy to understand, describe, and analyze. So that's why we decompose the problem. That is when you have a complex problem, right? But when you have a simple problem, no need to decompose. For an example, let's say adding two numbers, number 1 and number 2, you add two numbers. You don't want to decompose that because that is a simple problem. But when you have a complex system or complex problem, we can decompose, right? Okay, so that is the first thing. And then under this chapter, we will be learning three things. We will be learning three things. One is sequence. Sequence is where the instructions are executed one after another, right? This actually grade 6, you had this, right? Sequence is where the instructions executed one after another, but at grade 6, සමහර අය කිව්වනේ grade 6 වල කරුණ නැහැ කරේ නැහැ කියලා. එහෙනම් මම පොඩ්ඩක් මේක විස්තර කරන්න. So basically we are using flow charts to explain or write algorithms. We are using flow charts to write algorithms, right? Sorry, a flow chart is it's a symbolic way of representing something. Rather than writing it in words, we used to explain it using symbols because the symbols are easy to understand. So can you remember what is the symbol? What is this symbol stands for? This is showing. Yeah, this is a rounded rectangle. It's showing start or end. It can either show the start or it can show end also. And what about this green color one, the parallelogram? Samantarashtrayak green color one, the parallelogram. What did it explain?
The second step. Sorry, sir.
Yeah, so I'm just asking. So what is basically the meaning of the symbol?
Input.
Parallelogram?
Input and output.
Yes, input or output, right? So it's not input and output both. It's input or either input or output. So that is shown using a parallelogram. Then this one, the rectangle. Process. It's process, right? The rectangle is showing a process. And what about diamond, the yellow color one, the diamond?
Decision.
Yes, it is showing a decision. And so when you have a decision, actually so let's say you came to a road where there's a junction. You have to decide either to turn right or turn left. In decision, basically your flow chart is directed to one way or other way. So you have to select this path or this path. That is the decision. But some flow charts are there. In those flow charts, the direction will lead to repeating of the particular path. That is called repetition. That means when you are directed to this path, you can see the arrows are flowing down and coming up, and it's going up again and again flowing down. That means it's repeating. The same instruction set is repeating. So that is called repetition. Okay, repetition is a cycle.
Sir, I can't understand repetition, sir.
Repetition is basically, okay, let's think simply.
Sir, can you give an example, please?
Yeah, you come to the class every day.
Yes.
Right? So that is the example. You come to the class every day until we finish the syllabus, right?
Yes.
You have to repeat the same steps. Log into the account, maybe log into the Zoom session, make available, learn, and then go back. Next day, when time is when a day is Thursday, when time is 7:40, you again join, right? And then you continue. So you do repeating these things again and again until you finish the syllabus. But when you are in grade 8, so you are in another class. You have to shift that. Until you finish grade 7, you have to come like this. There is example.
So that means the end is finishing the syllabus.
Yeah, end is finished. Once syllabus is finished, it is stopped.
Yeah. I understand.
Until the syllabus is, that means until syllabus is there, you have to come and learn, learn and finish. This may be, okay, let's see, take simple example. How you came from grade 1 to grade 7? is sequence.
Going
Grade 1 you have
going
passed,
to send
then
food.
came to grade 2, then grade 2 passed, grade 3, likewise. It's sequentially you came to grade 7. But in all levels, in ordinary levels, you have to select a subject scheme, right? So maybe you are after all levels, you will select math scheme or science or art or literature or commerce, like that is a selection. But there are some students in A levels, they do repetition. What is that? First time they are trying. If they fail second time, they are trying. Third time they are trying. They are trying to go to the university several times. So that is another example for sequence, selection, and repetition. And let's take that from the computing angle. Okay, how you log into the computer is sequence. First of all, you start the computer. Then the computer will start and ask you details about the login details, username, password. You provide it, then validate, and you are given the login screen. That is sequence. And in these menus, you can see I'm using MS Word. I'm selecting home ribbon, home tab. Then I'm selecting insert tab. Then draw tab, design tab. Actually, in particular given time, I can only select one tab. I can't select multiple tabs, right? I can't select both home and insert. That means I have to select. I have to select from alternatives. I am given different alternatives: home tab, insert tab, draw tab, design tab, layout tab, references tab. Likewise, different tabs are there. I can select only one tab at once. When you type in, you have to finish the first line, go to the next line. Finish next line, go to the next line. Likewise, repetitively you have to type. That is repetition. In any programming language, you have sequence, selection, and repetition. Because in computers, we are using all three control structures. Actually, this is how we control the program flow. Can you understand it now? Or still
Yes,
difficult?
sir. Now I
Right. Okay. So that is what the control structures are. So based on a condition, you have to decide, that is selection. Based on the condition, you have to repeat, that is repetition. Okay, so here you can see they have given a nice example for sequence. So when you climb a mountain, or when you actually go through the staircase or ladder, right, you can see you go step by step. Start, right? Here actually they have given example how to put a cover to your book. Start, cut the paper required to cover the textbook in a suitable size. Place the textbook on the paper, fold and cover inward, then paste inside, close the edge and edge of the outer cover. Label your textbook in front of for the identification. This is how you, maybe several steps are different, but anyway, you can see some matching steps are given explaining how to put a cover. Okay, so let's go more practically and let's write a code, or let's draw a flow chart for sequence, and then try to implement that using stretch programming interface. Okay, grade 6, you did not actually learn this stretch, but some of you have learned. I'm not sure. Some of you have done, but some are not. Therefore, let me explain that also. Okay, so this is what the stretch interface is. And right, this is given in your book, so no need to name them, but if you want, you can take a screenshot, because when you take a screenshot, so then you can compare that with the book. Yes.
Screenshot now. Oh my god.
Cannot hear you properly.
No, I'm taking a screenshot, sir.
Okay. Right. Okay. So now you can see these are the parts, right? These are the parts of the stretch screen that you'll get. I'll send you the link, Pute. So to load stretch, you can go to stretch.mit.edu. MIT is a leading university. They have developed this for encouraging kids to write programs, right? So when you go to this Stretch website, you can see start creating, and I'll send you the link. Copy and paste the link for you. Yeah, you can follow the link.
Box, sir.
Please follow the link which I have sent. When you go to the particular website, you can see start creating. You can click on that. That will load the Scratch interface. That will load the Scratch interface, and this is it. And you can see there's a cat. So he's called Sprite. Sprite is the actor. He's going to act according to our instructions. And you will see a tutorial window that you don't want for the moment. You can close it. You can close it. You can close it. And this is where you write the programs. And this is where the programming blocks are there. And this is it. This is your Scratch stream. Right? Sprite. This is where the sprite moves. And sprite controls are there. You can control the sprite size. Maybe if you don't like 100% cat, you can put 50%. Then the size will be reduced. Here, when you put 50, size is reduced. And direction also you can change and rotate it. You can see it's rotating, rotating, and rotating. If you put 90 degrees, so it will look at the right side. And the position also. So this carefully you have to identify. Do you know the Cartesian plane which you have to learn in mathematics? Cartesian plane එක දන්නවද? Maths වල ඉගෙන ගන්න.
Yes, sir, but still we haven't learned that in our.
Oh, you haven't learned that. Okay. So anyway, all right. Anyway, in this Cartesian plane, I'll draw it for you. Cartesian plane කියලා කියන්නේ something like this. So it has, this is called y direction and this is x direction. This is x direction. අපි මේ ඊතල දාලා තියෙන පැත්තට හේදමු. X direction is going from left to right and y direction is going from bottom to top. In the middle of this Cartesian plane, it is 0, 0. When you manually put 0 here and 0 here, so cat is going to 0, 0 position in the Cartesian plane. Can you see? You can change and see, right? I think you load the interface. Phone එකේ හැරි වට load කරන්න පුළුවන් පුතේ. Load කරලා ඉවර වෙලා put 0 to x and 0 to y and observe where the cat is. Now cat is in the center. Okay. Is it working?
Okay.
Right. When you got 0 and press enter, right? Okay, let's change x to, I'm going to change x without changing y. I'm going to change x and I'm putting 250 for x. Sorry, 240 for x. When I put 240, you can see cat is going to the corner. So that is where the highest x value is. X is increasing and from left to right. When you put 240, x, the cat is going to the right corner. It's going to the right corner. Observed, I think, okay, right? So 0 in the middle, 240 in the right corner. So what about the value in the left corner? Can you predict? What about the value in the left corner?
Minus 240.
Yes, it is minus 240. Value in the left corner will be minus 240. So then it will be there in the left corner. That is how you change x. In between, you can put any value. Maybe you can put 100. So then you can see cat will be there in the 100 location 100. When you put minus 100, it will come to the left. Likewise, you can change the cat x position and move the cat. Okay, I'll tell you how to do that, right? So when you're going upwards, the top position is 180. 180 is the top position. And the middle position is 0. And for y, minus 180 is the bottom position. Right? Minus 180 is the bottom position. Okay, if I want to move the cat to every corner of this, that means all 4 corners, I have to code accordingly. So let's do that and learn how this behaves, because it is needed for the actions. From the events, you can see the yellow color one, that is the control event. And we learned the interface, right? I think you can remember the interface, right? So this is where the different code segments are there. And you can see the file menu, edit menu over there, and the code blocks in the middle. This is the scripting area that is in the middle. That is where we are going to drag the code. Start and stop. Flag is for start and this sign for stop, red one. To make it full screen, this symbol is there. And to backgrounds, you can import from this. Sprites you can change from here. And you have extensions there in this corner. Right, and you have X and Y directions too. Okay, this is about your stream and the tutorial. You have closed that. Okay, let's move the cat and understand what will happen. Now I just want to move the cat from here to here, then here, come back, go there, come down, likewise. Okay, let's code for that. When I start, when I click the flag from the events, I'm going to drag it, click and drag it here. Then I'll go to the motion. I'm asking cat to start from 0, 0 position. Hey cat, please go to 0, 0 position, go to the middle. When you start, go to the middle. So then cat will be in the middle. Then I'm asking, hey cat, glide to X, okay, like X240. Please glide to X240 and Y0. You can see the cat is moving to the corner. I'm asking to the cat to come back to the other corner by duplicating this and put in -240. Then cat will go to the other corner after that. Going there and coming back. Hey cat, go to the center back. That is 0, 0 position. Duplicating again. Hey cat, go to the top. That is 180. And finally, I'm telling, hey cat, go down. That is -180. Then I'm asking, please come back to the original position of 0, 0. Okay, if I write this code, and so let me erase everything in the stream. If I write this code and execute this, you can see cat is going this side, yeah, then come to the center, go up, go down, and come to the center again. Okay. Okay, after that, I want it to go to this corner, this corner, this corner, and this corner. Can you code? Can you tell me the values?
Yes.
What's the value for this corner?
Glide 1 to. Sir, which corner, sir? I couldn't see which corner. Then
Yes.
it must be 1 minute, sir. 240.
Can't give a minute, I'll give 10 seconds.
Okay. Anyway, just a minute.
Any one of you can tell the answer. What is the coordinates here? What are the coordinates?
Sir, isn't it something like 200?
So here you can see the top is, what is the value for top? Y top is 180.
240.
180, right? Top is 1, then the X will be the negative. X is -240.
180, sir. Then 100, something like that. No.
Yes, you can say X is -240 and Y is 180. That is this corner, right? Here it's going here, yeah, going up, coming down, right at the center, come to the corner.
Sir,
Yeah.
when we click flag, it will start, right?
Yeah, when you click the flag, it will start. Can you tell me the other corner? This corner, what are the directions? What are the value for this corner?
That corner, it must.
All of you need to talk.
X plus 240 and Y 180.
Yes, x plus 240 and 100. Correct. Exactly. X plus 240 and
180.
180. Yes. Then the bottom here. Bottom right. Bottom right.
Bottom right, then sir, it must be
X
180 to 240. No, not 40.
X is 240. Y is minus 180.
Minus 180. That's what.
Yes. Then
240 to
this
minus 180.
bottom left corner, X is minus 240 and Y is minus 180. Okay, likewise, you can navigate it to any corner, any area by giving the coordinations. Right, that you should learn. Right, you can glide to any corner, any area by, right, you can glide or you can move to any corner by giving the directions. Okay, understood this?
Yes,
Anyway,
sir.
how we have given the instruction is called sequence because we gave instructions one after another. One after another. Sequence. One after another. Okay, let's go and learn how to solve a small mathematical problem using this. How to solve a small mathematical problem using this. Now you know how to code, how to write a small code, how to move the cat from one corner to another corner. So there are more things, right? There are more things that you can do. So let's explore that one by one. But before that, let's go and solve small question. Right. So the first thing is why we are using flowcharts to solve an algorithm, because as I said, flowchart is a clear way of giving instructions. Right? Please read out. When we want to solve a problem using a computer, we must write a readable programs. Before writing such code, we need to clearly understand the problem. Right. So we learned that the complex problem need to be manageable, need to be decomposed into the manageable pieces to understand it. To clearly understand the problem, we must declare. Right? We must create a clear plan. Actually, the plan is created by using flowchart. Why we use why we use flowchart instead of the natural language? Because natural language might be ambiguous. What do you mean by ambiguity? What is ambiguous?
Sir,
Ambiguous
that's
means?
connection issue. Ambiguity. I mean.
Yeah, ambiguity. What is ambiguity?
Say the correct answer or something like.
Ambiguity means in Sinhala we can call patalili sahagatai. So it's unclear, somewhat not clear, because the instructions are given in the words. So you can see these are a lot of words. Right here also you have a lot of words. When you have a lot of words, it's like, oh, looks boring to you. One thing, and another thing is like, so sometimes you won't get the meaning exactly. But you can write this. You can write this in your book. But getting meaning or understanding the meaning will be little difficult. Because different people will understand meaning in different way. එක කෙනාට එක එක විදිහට තේරෙන්න පුළුවන්. ඒ හින්දා තමයි කියන්නේ මේ flow chart එකක් වගේ. flow chart වල තියෙන symbols නේ. When you use symbols like this, it is easy to understand because everyone will understand what is this. So this is either stop or stop, start or stop. Everyone will understand what is this. This is input to output, process, decision, connector, and the data flow. Everyone will understand that. Okay, first please write down this one. Use of flowchart to represent an algorithm. Why we use flowcharts? to represent an algorithm? The answer is this. Please write down this quickly. Why we use flowchart to understand programming? The answer is this. Actually, by using a flowchart, we are showing algorithm, right? All these words are there in grade 6, right? Algorithm, flowchart, ambiguity, all these are there in grade 6, but I'm explaining since you said that you have not learned. Some of you have not learned කියලා කිව්වන්නේ සමහර ඉගෙන ගෙන නැහැ කියලා grade 6 වලදී. ඒ හින්දා තමයි මම ආයෙ විස්තර කරන්නේ. flowchart එක හදාගෙන අපි flowchart එකෙන් කරන්නේ plan එකක් හදන එක. සිංහලෙන් කිව්වොත් plan එකක් හදන එක තමයි flowchart එකෙන් කරන්නේ. plan එකක් වචන වලින් ලිව්වොත් පැටලෙලි සහගතයින්ද තමයි symbols පාවිච්චි කරලා ලියන්නේ. Right? So this has all these things clearly. So plan එක කියලා කියන්නේ අපි algorithm එකක්. Algorithm එකක් කියලා තමයි සිංහලෙන් කියන්නේ. Algorithm එකක් කියලා කියන්නේ ප්‍රශ්නයක් විසඳන්න. To solve a question, if you write to solve a problem or question, if you write instructions clearly with the steps, we call that as algorithm. Okay, please write this and let me know once you are done. And if you disconnect from this session, please reconnect to the same link because we are going to continue with the second session. Disconnect or not, I make it connected.